All right, so here's the key to week one's homework, which hopefully you all did. So mass-to-mass problems. The thing with mass-to-mass problems is that it puts a lot of things together we've learned. Okay, so if you make a mistake one spot, it can get amplified, and you do 90% right, but you can still get the answer wrong. So you've got to pay attention to detail. Okay, so let's look at this, the problems here, and make corrections as we go. Also, this key is also in the Google folder, so you can access it there also. All right, so here we go. First thing, you have to write the correct formula to get the correct equation. So iron 3 hydroxide is FeOH3. Okay, sodium hydroxide NaOH, and then iron 3 chloride would be FeCl3. Right, because iron's a 3 plus there, that's a 1 minus. All right, so you've got to make sure you write the correct formulas. Then to balance it, okay, you should do it balance, end up with a 3 here and a 3 here, so it's 1, 3, 1, 3 ratios. All right, so first thing you got to do is you got to figure out how many moles of NaOH you have, because they give you 23.7 grams of it. All right, so you take 23.7 divided by the molar mass of the sodium hydroxide, which is 40.01, and you get 0.592 moles of NaOH. All right, that should be easily done by you, but that's the first step. Second step is to convert into moles of iron hydroxide, because they're asking, that's what the question's asking for. All right, so it's a 3-to-1 ratio, so 3 is to 1, like 0.592 is to X. All right, just make sure when you set up these ratios, if you have sodium hydroxide on the top here, okay, it's got to be on the top over here, just be consistent. So 3 is to 1, like 0.592 is to X. Solve for X, comes out to be 0.197 moles of iron hydroxide. All right. So once you have that, then you have to go from moles into mass. Okay. So mass is moles times the molar mass of the iron hydroxide. So it would be 0.197 moles times 106.88 grams per mole, end up with 21.1 grams of iron hydroxide. Right. So that's question number 1. Right. Question number 2, let's go to it. Move it up here. Again, make sure we write the correct formulas. So it's NaOH plus phosphoric acid. Okay, so remember phosphoric acid, we have to go ic is to 8, so that means that the phosphate, which look up in your iron chart, it's PO4 with a 3 minus charge. H is hydrogen is always a 1 plus charge, so it would be H3PO4. Okay. And then sodium hydroxide NaOH. Okay, so there's the formula, and then you balance it, end up with a 3, 1, 1, 3. All right, so there's the balanced equation, correct equation there. Then mass to moles first. Okay, so if you got, they give you is 3.65 grams of the sodium hydroxide, so 3.65 over 40, end up with 0.09125 moles. We'll do significant digits later. Again, do the mole ratio. Okay, 3 is to 1, like 0.09125 is to X. Solve for X, comes out to be 0.0304 moles of the sodium phosphate. And again, mole to mass. Okay. Moles of sodium phosphate times its molar mass. Okay, you come up with, I came up with 4.98 grams of sodium phosphate. I know the key says 4.99. Okay, different periodic tables are off a little bit, so that's both would be acceptable. Okay, part B. All right. How many grams of phosphoric acid does this already produce? 84.8 grams of water. Okay, so you have the moles of water. You can figure out moles of water first. Okay, so 84.8 over 18.02 equals 4.71 moles of water. All right, again, mole ratio. Okay, the phosphoric acid to water, 1 is to 3, like X is to 4.66, so you end up with 1.57. Okay, I made a mistake the first time, but corrected it. 1.57 moles of phosphoric acid, and then again, convert that into mass. Okay, moles times the molar mass of the phosphoric acid, and you end up with 153.86. Significant digits takes it to 154 grams of phosphoric acid. All right, flip it over, backside here. All right, here we go. Single replacement reaction. Okay, silver nitrate reacts with copper metal in a single replacement reaction. Copper 2 nitrate is one product formed. Okay, they want to know what the mass of copper used. Okay, so now we're just looking. You have the silver nitrate plus copper makes silver and copper nitrate. Okay, and then you balance it. So there's a balanced equation there. Okay, they give you how many grams of silver you want to obtain. So you get the moles of silver first. So 67.2 divided by 107.87. You get 0.623 moles of silver. And then you just look at the mole ratio of silver to copper. Okay, it's a 1 to 2 ratio. Okay, so 1 is to 2, like x is to 0.623. You end up with 0.312 moles of copper. Again, change that moles into mass. Moles times the molar mass of copper, you get 19.8 grams of copper. All right. And then finally, here we go, last question. They want the atomic mass, all right? So atomic mass, you know, is grams per mole. Okay, you know how many grams, they give that to you in the question, 0.126. So you got to find the moles of M. All right, so set up the equation. So M is the metal plus hydrochloric acid makes hydrogen gas. Now remember, hydrogen with oxygen, nitrogen, and all halogens, it's diatomic, so it's H2. And then MCl3 was given to you as a product. All right, so you end up balancing it 2, 6, 3, 2. All right, so we want to figure out how many moles of M we have. And that's a 2 to 3 ratio of hydrogen. Okay, so 2 is to 3, like x is to 0.00700. You can keep it in scientific notation if you want to. I choose not to. Okay, then just cross multiply. X is 0.00467 moles of M. Okay, atomic mass is grams per mole. So your grams is there, your moles is there. Ends up with 26.98. Rounds off to 27.0 grams per mole, which, of course, looking up periodic table, turns out to be aluminum. Again, this key is in your folder, so you can check your work against it. Yeah, any questions anytime, just give me a call, and hopefully this is all coming together for you. All right, till next time, so long.